6.3, sums of radicals, and we're going to be adding and subtracting square roots. In order to add or subtract square roots, you have to have the same radical inside. So the first thing you want to do is to find your buddies of 8, so that's 4 and 2 and 2 and 2. So you have 2 radical 2. Then we're going to go ahead and simplify this radical to square root of 98. You can have 49 and 2 and 7 and 7. So you would get 7 square root of 2. If you notice, you have the same radical right here, square root of 2. So since they're the same, you can add the numbers in the front. So you'll have 2 plus 7, and 2 plus 7 is just 8, 9. So we have 9 square root of 2. B, I have the cube root of 81 minus the cube root of 24. And if you notice, these are both cube roots. If they're not both cube roots or they're not both square roots, then you can't add or subtract them. They have to be the same root. So we're going to have to find 3 numbers that multiply together to get 81. And so we're going to have 9 times 9 and 3 times 3. And we're going to find our buddies of 3. And we have 3 cube root 3. So you have 3 left over. Minus here we'll find our buddies of 24 is 8 and 3 and 4 and 2 and 2 and 2. So you will have 2 cube root of 3. So if you notice, again, we have common, in this case, cube roots. So we can add the numbers, or in this case, subtract, because it's a subtraction sign. You can subtract, and it's 3 minus 2, which is just 1 cube root, with the cube root 3, or you can just write it as the cube root of 3. You don't have to have the 1 in the front unless you want to write it. It's right either way. C, I have the square root of 32 over 3 plus the square root of 2/3. First thing you want to do is to rationalize these, which means to simplify them. So I have the square root of 32 over the square root of 3. And let's just look at this one first. We know we can't have a radical on the bottom, so I'm going to multiply the top and the bottom by radical 3 so that they'll go away. And you'll have 32 times 3, which is 96. And 3 times 3, which is 9. And the square root of 9 is 3. Then we have to find buddies of 96. So 12 and 8. 4 times 3 is 12. 2 times 2 is 4. 4 times 2 is 8. And 2 times 2 is 4. So you have buddy here, a buddy here. And so we're going to have 2 times 2 on the outside. And then on the inside we have a 3 and we have a 2. So we have 3 times 2. So this is going to be 4, 2 times 2, and 3 times 2 is 6. And our denominator was 3. 4 and 3 do not reduce, so this is our answer. For the top part, I should say. Make sure we understand that was just for this. It's not your final answer because we still have to add this together. So now we have to rationalize radical 2 over radical 3. Again, you got to multiply the top and the bottom by radical 3. 2 times 3 is 6, and 3 times 3 is 9. Square root of 9 is 3. And you can't find buddies of 6, so you're going to leave it alone. So that's the answer for this one. So now we can add these together. We're going to have 4 square root of 6 over 3 plus square root of 6 over 3. And remember, there's still imaginary this answer, so I wrote it here, and this one we rationalized and got this answer. So now we're going to add these together. What's important to remember when you have fractions is you have to have a common denominator still, and you have to have common square roots. So you're looking for two parts, because in order to add fractions together, you have to have a common denominator. Luckily we do. And here we also have common square roots. So we're going to have 4 plus 1 is 5, and we just have our square root of 6. Example number 2, I have a is square root of 6 times square root of 2 plus square root of 3. When you're multiplying square roots together, because we have to distribute for this one, you have to multiply the insides together. So remember, when you're adding or subtracting, you have to have common square roots, and the number inside the radical sign never changes. However, here you're multiplying the insides together. So we have 6 times 2 is 12, and 6 times 3 is 18. So now we have to find buddies of 12. So we'll have 4 times 3 is 12, and 2 times 2 is 4. So I'll get 2 square root of 3 plus, and then we have 9 times 2 is 18, and 3 times 3 is 9. So I'll have 3 square root of 2. And if you notice, these are not common square roots, so you cannot add them together. So you have to leave it alone, and this is fully simplified. You can't do anything else. B, I have the square root of 21 plus the square root of 15 over radical 3. I'm going to go ahead and put the radical 3 under each part of the fraction here. So I'm going to break it up so it's under the 21 and it's under the 15. When you're looking at these, if you can try to write these as one radical. And we had an example in last night's notes like this. And if you write it as one radical, 3 goes into 21 7 times. So you could reduce it that way. And also, 3 goes into 15 5 times. So you can go ahead and simplify it like this, and you have radical 7 plus radical 5. They're not common square roots, so this would be your answer. Okay, we have 2 more and then we're done. Example number 3. The square root of 12 x to the 5th minus x square root 3x to the 3rd plus 5x squared square root of 3x. Okay, so we're going to look inside the radicals and we're going to see if we can simplify them. Well, here let's just look at the number first, and then we'll look at the variable. We have 4 times 3 is 12, and 2 times 2 is 4. So we know that we have 2 square root of 3. And then we have x to the 5th. So you're looking at 5 x's. And you're finding buddies for those. So you have x times x, which is x squared on the outside, and you have 1x left over. Here we know that we can't break up radical 3, so it's just radical 3, but we have 3 x's. So that means 1 is on the outside, and 1 is stuck on the inside. However, you still have this x that was already there. So you have the x that was already there, and the 1 we took out from this part of the square root, because there was 3 of them. We have 2 partners, so that becomes 1, and then you have the 1 left over. So really here we're going to have a negative x squared. this one. Can you simplify that? You can't find buddies for anything. So now we're just looking at this question. And if you notice, we have common square roots. So we can add or subtract here. So I'm looking at 2x squared minus x squared plus 5x squared. So when we look at that, and it's still radical 3x inside, we look here and I have 5 plus 2 is 7 minus 1 is 6. So we have 6x squared radical 3x. Last one, B. I have the square root of 6y minus the square root of 3y over square root of 2. We know we can't have a square root in the denominator, so we have to multiply by radical 2 to the top and the bottom. So I still have my 6y here, and then I'm going to subtract. Here I have, remember when you're multiplying the inside of the radicals, so it's 3 times 2 is 6y. 2 times 2 is 4, square root of 4 is 2. So remember, there are two things you have to have. You have to have common square roots and common denominators. So I have to multiply this by 2 to the top and the bottom. So I'm going to have 2 radical 6y over 2 minus the square root of 6y over 2. My common denominator is 2. And remember, this is an imaginary one. These are the same square roots, so we're going to do 2 minus 1 is 1, and we have a 6y. 6y, you just have 3 times 2, so it won't break up, so this is your answer, and you can't reduce 1 and 2.